Okay. Bring up another picture.
Oh, if you want that. Sorry about this.
Oh.
Which one?
Let's see. Make it down. That one.
This one here?
Yeah. Oh. That's cheaper, no?
Not that one.
I know what you're doing because I have this program.
Oh, yeah. Okay, which one?
Jeremy?
That one.
Jeremy,
This
while
one?
you're
Yeah.
looking, and pointing at some, one of the things that I noticed about your pass arrays is that relative to their weight, they're amazingly sturdy because they're all comprised of stacks of triangles.
Yes, that's true. And the dodecahedron, which is that one next to the straws, is all squishy. On one of my that one. It's broken, but it's also squishy because it's not triangles.
Right.
Yeah. This thing is called a takraw, and it's in Thailand. These are computer-made models, but if you can imagine these made of rattan vines, and then it's a game, and the object is to kick this ball around and keep it off the ground. So it's probably the progenitor of Pakistan. These ones were models that the guy made, but the ones on the bottom are really the ones that the real takraw actually looks like. And that's all right. Well, I know. I can't see it. Anyway, so the takraw is the only known thing in existence that I'm aware of that's the same as this. And the 10-banded objects, which like this, but more bands, I've seen in Japan as pictures, and it's called tamari ball, and it's a sort of a ritual gift made of bits of clothing, but woven in exactly the same way as the 10-banded shape that we saw earlier. Yes, and then going back to that plastic ball. Yeah, that plastic. Well, let's see. Let's do. Well, let's do. Yeah.
Okay.
Yeah. So this plastic ball. When I made the 10-banded thing, I went down to the toy store and I found this, which is basically identical to my 10-banded thing. So this does occur in the West, as it were, but basically that's virtually exactly the same as a soccer ball. You've got the standard black and white ones with pendulum hexagons, and so my point there is that in the West we have the soccer ball, and in the East we have the takraw and the tamari ball. And but more to the point, I would say, is that if you go to Home Depot and you want to get tiles that are not square or rectangular, you're hosed. You can apparently get hexagonal tiles, but they're glued to a square mat. And and in tiling the plane, you can get you can tile a plane with triangles, with diamonds, with hexagons, and with squares. And the West only uses squares. How boring! And the East, you go to the
or with Penrose tiles.
That's indeed. And if you go to the Math Department of Cambridge, Austin, Texas, and a couple other places, you'll see Penrose tiles. And I've got something to show you. But otherwise, yes, if you go to the East, you go to all those Islamic temples, and they're just chock full of all kinds of amazing tile designs. And so I reckon that a good knowledge of Polyhedra would be most excellent to sort of spread more, just so that we have more imagination, more tools to work with their imagination in all kinds of fields. Which brings us to a semi-final point, which is
That's essentially the truncated icosahedron, or maybe you said that. The Buckminster Fuller's units and dome, basically hexagons and pentagons.
yes, and the 10-banded object. Oh, here
It showed.
yeah, this one is the 10-band object, made of steel tines. I don't think it's about Buckminster Fuller, It's very closely related. I think it's actually better. I'm curious in terms of if it was possible to make larger things than this, if they wouldn't be more robust than the buttons floating. So anyway, something to one of my future projects. Yeah. Okay. So if you can just show. Let's see. Yeah, just show that one, and that one.
After the third one, I forgot.
Okay. Anyway, this is in the local bar in Corvallis. It's a dodecahedron made with beer coasters. So it's a coasterhedron. I'm just showing you different ways you can make these things, and basically I made half of these things with just junk like that, coasters and cornflakes packets and all kinds of stuff. Yeah, the next one's that. Yeah, do a let's see.
Yeah, that's the truncated
So this one next.
Yeah. This is a 6-pound thing made of light sticks. And so light sticks.
Oh.
Yeah, and so there's a great fun at festivals and parties and that kind of stuff.
This one here, the tree.
Yeah, sure, yeah, that one must be. Yeah, so this one is a 12-banded object made of 2-inch iron strips that I found on the railroad lines under some railroad ties. So I presume these are the bands that hold the railroad ties together when they're delivered on the pallets. And anyway, it makes a nice garden sculpture. And the whole thing is woven together, and nothing's holding it. Nothing's no glue, welding, tape or anything. It's just all holds itself together. And like this thing, it's even though this is incomplete, it's still pretty robust. So and it's just and this is made of cardboard. It's also pretty robust, and that's why when these things show up in Thailand, it's like a cultural artifact, and it's the evolution of the most regular and robust shape, one that survives and can withstand kicking around and so on. And so it's like this thing to me it's evolved. So. And then what's the relevance of Polyhedra? Well, I've got a picture of the tree of life here, and so you've got your Darwin and monkeys and fish and ferns and all the rest of it, and then here we go down to the bacteria and the polyps and all that stuff. Right in the centre, they've got various viruses, retroviruses, prions, RNA, and all that stuff, and they're all icosahedrons. So they have your icosahedron and the centre of the tree of life. And I've actually got a ton of pictures on this computer, which I forgot to copy over, but anyway, it's just endless viruses, and they classify viruses by a thing called the triangulation number. So that's the T in some of those, retro T or whatever, and that's related to the relationship to the icosahedron, and so it's right in the middle of it. Here I've got a paper by an English mathematician, Polyhedra in Physics, Chemistry and Geometry, where they describe quantum mechanics structures, and many of them are polyhedral shaped, and then in many atomic structures have polyhedral structures, and then in chemistry you've got molecules, and some crucial ones have polyhedral structure, and then of course geometry itself. And the way I explain this at festivals and so on is that the universe is space-time and complexity, let's say, and if you're going to think about space, the polyhedra, if you become familiar with them, is a great way of, like, a starting point to think about space. And so again, I would say it seems like we've missed out on the fact that, in general, polyhedra aren't like studied more in general Western education. I think I'm about done, but I'll just show the rest of these pictures just for fun of it. The models that I have, by the way, consist of just models of polyhedra. So here's dodecahedron, but then sometimes they're thematic. So this can have a calendar because there's 12 sides and 12 months. And I've actually made one for 2011. I didn't get a chance to print it out, but I'll put it on my webpage, and then you can all access it. And then find your favourite 12-year-old nephew or niece to cut it out and make it for you. And then this one inside has mirrors. So if you get some flashlights, there's 4 little holes. Look in one hole, put the flashlight in the other holes, and you'll see this infinite dimension of a dodecahedron structure.
Display pictures of the inner surfaces of the pentagons. I saw that yesterday.
Yep.
Yeah.
They're displayed in mirrors.
They're actually silicon wafers, but yes, they're serving as mirrors. and there's a big dent where I got crushed in. Now, yes. Okay. Well, this is a icosahedral compost bin. This is my neighbour's icosahedral garden shed. These are different forms of that 6-banded figure made with iron, plastic, and 3D glasses. In fact, if you click on that one, you can see it. Yeah, see, that is 3D glasses. So you can do anything. If you then get back to that picture. And yeah, and then now if you can drop that file into a browser, it's now Jeff. Yeah, so just drag the file. Yeah, there you go. Yeah, there you go. This is a rotational 8-pack. Much more interesting than 6-pack. And actually, if you can play that again, there you go.
Oh wow.
Now I've got a model of this, but just in cubes on somewhere around here.
Do you have any with full cams?
I gave one to a friend of mine, but let's see how much we got.
You're probably really bummed because I threw away your canvas.
Yes, in my house, people are not quite sure what to throw away and what's important. Oh, we get that one.
This one.
And then that one. Okay, so this is the thing I made out of hot and cold water plastic piping, and then the tennis balls are added as spacers, so that it becomes rigid. And this thing's about 6 foot tall, and I took it to a local festival that we have, and that other picture shows it for the kids. Yes, that's the other picture.
Oh.
Yeah. Alt F C.
Alt. Sept.
C. Oh, yeah, and then so there's the thing at the festival, full of kids. Yeah, and no doubt, and they literally.
Put it high there so we can hear it.
But they seal in it.
Pretty
Big bowl, so throw some kibbles in.
Okay, is that it?
Yes. Final point is that all the models are on my webpage. So get the gist of me if you're interested. And you should have cards to hand out, but I'm infinitely unprepared this time. And all the rest of this stuff will also be on the webpage eventually, sooner the better, so that you have a sort of a complete reference to making, building, and analysing polyhedra for fun and pleasure. Thank you.